Hello and welcome back. In this video, I'm going to share the solutions for problem N slimes from Atcoder Educational DP contest. Let's go over the problem statement. There are N slimes lining up in a row, and essentially the ith slime from the left has size of A of I, and Taro is trying to combine all the slimes into a larger slime. We'll perform the following operation repeatedly until there is only one slime left. So the operation is that we need to choose two adjacent slimes and combine them into a new slime. And the new slime has a size of x plus y, which is the sum of the corresponding sizes. And the cost incurred in this operation is the sum of their sizes. And the positional relationship of the slimes does not change while combining slimes. Find the minimum possible total cost incurred in this. So the constraints are n is up to 400 and the sizes are up to 10⁹. So let's try to figure out what this operation is going to look like. Suppose we are given an array of size 4 and we had values 1, 2, 3 and 4 in them, and we want to perform the operation from the nodes, adjacent nodes 2 and 3. This will result in an array which has size 3 because we are combining these two. We're combining these two into a single slime which is of size 5, and the other ones remain same. And since they have mentioned that the positional relationship remains the same, this is what they mean. And the cost occurred in this operation is 2 plus 3, which is the sum of the slimes that were present while merging. And next, let's say we merge these two. Notice that the cost that we need to add here will be depending on the new cost of the merged interval. So 2 and 3 were merged, they became 5. Now the cost for this would be 5 plus 4, which is 9, after merging the second and third into 1 and 9, right? And again, this would be obvious to make it a 10, and cost would be 10 here as well. And the total cost to reduce the initial A, let's say A1 to A2, then A3, and then finally A4, would be the summation of these three values. So first operation took 5 cost, second one 9, and the third one 10. This is not optimal, but I'm just trying to explain the simulation of operations that will be performed one by one. So notice that the cost that we need to consider will depend on the value that was merged before performing that operation. As you can see, this 9 was taken from the last 3 elements of the array. So 2 plus 3 plus 4, this became 9, and combining these two, it became a 5, and this became a 10 by combining all the elements 1, 2, 3, 4. But the cost that was responsible for performing the operation from one after the other, from A1 to A2, then A2 to A3, then A3 to A4, will be depending on what ranges you are going to merge. Yeah, that's it about the observation. Let's try to figure out some cases. Suppose we want to know the answer for a single array element. So let's say the array only consists of one element. In that case, the answer is already known or already in this final state. That means we don't need to merge or perform any operations. It is already reduced form. In that case, the answer will be 0. So say we want to know the answer for any range L to R, which will be represented by this term. this will be 0 whenever L and R are same. So we are essentially interested in finding out the answer for any sub-array of the original array A. We want to know what is the answer for a particular right and left hand point. Now let's say there we want to know the answer when L plus 1 is R, which means the subarray has two elements, two length of subarray. In that case, the answer would be the sum of those two elements, because we need to merge them, and there is only one way to merge them, right? To combine them into a single array, single entity, and that would be the value at lth position plus value at rth position. So this case is when L plus 1 is R, which is there are only two elements in this subarray that we are going to merge or find the answer for. So this is the main idea. Now let's look at when we want to merge three of them. So to merge three of them, so the first choice is to keep 3 as it is, and first merge 3 and 4 and 5. This will take the cost of sum of A4 and A5, and after they are merged into single, they will form a structure like this. 4 5 are merged, and now to merge them we will find out the total cost, which will be sum of the nodes or the array that we are combining to. Since 4 and 5 are a single entity now, their total value is A4 plus A5, and A3 is again a single entity, but the cost of making it a single entity is 0. Hence the total cost to make in this choice 1 would be A4 plus A5. And if we keep 5 as it is and first merge 3 and 4, in that case, to make 3 and 4 a single entity, 3 and 4 as a single element, it will incur a cost of A3 plus A4, and to make A5 a single entity, it will cost 0 because it is already a single entity. And again, combining these two, we will be combining 3 4 and 5. This will take A3 plus A4 time or cost. Okay, so these were the two choices that were available for a case where we are considering that we need to merge the subarray from indexes L to R into a single array by performing the operations that are available in the question. And there were two choices: either keep the first as it is, merge the last two, then combine them, or keep the last one as it is, first merge the first and second, and then combine it with the last, and so on. So if we try to figure out what this looks like for any subarray, so we want to essentially find out the answer for any subarray of this original array, and the final answer will be answer from 1 to n, since this denotes the entire array A, which is given. Now let's try to figure out how we'll find out this. So again, for the condition where length is 4, this is the visualization for that. So L will be at index 3 and R will be at index 4 for some example. Now we will merge any subarray from index L to, let's say, K, and it will partition the array into two parts from L to K. To L to R will be partition L to K, and K plus 1 R, right? So these are inclusive ranges, and to combine them, so L and R will decompose into L to K and K plus 1 to R, and the cost of this operation is the sum of elements in this range, right? And the best possible answer for this would be computed recursively from this function. So we will to know the answer for L and R, we will ask what is the best answer for L to K plus the answer for L K plus 1 to R, and the cost is the sum of the ranges that we are combining. So this is the main idea. So to find out the answer, let's say dp of 3,6, let's say the answer is denoted by dp, we will combine this, we will go over all the choices that are possible to combine between 3 and 6. So 3, 4, 5 and 6 was the subarray that we need to know the answer for. Then the first choice could be to keep 3 as it is, merge the last 3 first, or pair up 3 and 4, then pair up 5 and 6, combine the answer to a single one, or take the first 3 and then they keep last one as it is. And these single entities are pre-computed, or the answer for them would be 0, but for this larger ranges they would again be recursively called into smaller functions which will return their answers individually, and we need to update them in this. So let's say for the choice, so for the choice where 3, 4, 5, 6, we want to merge 3, 4, then 5, 6, then dp36 would be the answer for considering this choice would be to minimize dp36 with the answer to decompose. So answer for this subarray plus answer for this subarray, so that we know what is the best cost to arrive at a to merge the intervals in the range 3 to 4 and merge the elements in the range 5 to 6, that will be denoted by dp34 and dp56. And the cost of merging these two into a larger one would be the sum of the elements in those, right? So this had the elements a3 and a4, so it was a single block with this sum, and this was a single block with a5 and a6. And now if we merge them into this larger block, the sum of that block would be the x plus y of the independence that we are adding up. So x plus y will essentially be sum of the elements in that range that we are finding the answer for. So a4, a3 plus a4 plus a5 plus a6, which is essentially the sum of elements in this range. And the cost to arrive at best cost to arrive at this subarray and this subarray, so which will be dp34 and p56. Hope this is clear. This is the main idea, to find out the answer recursively one after other by considering the choices for the merging of intervals. So let me try to explain it a bit better. So the main idea for this type of problems is to create or think of it from bottom up approach. So essentially for any L equals to R, the answer was 0. For any case where L plus 1 is R, the answer was AL plus AR, and so on. So we are essentially merging these two into something, then this into something, then these two, let's say these two are merged, these two are merged, and all this merging happens one after the other, and this will essentially create a binary tree. And the root of the binary tree will denote whether, so all these elements will be considered. Don't take the diagram in the literal sense, but this will create a binary tree. And we need to know what is the cost to arrive at this node, and the costs to arrive at this node would be the sum of the costs to arrive at this any path from the leaf node to the root, which has the answer for the entire array. So for all the possible binary trees that are available that can be generated, we need to know the answer for which the sum of these values is minimized. So these choices are the merging of intervals. If there were multiple of these in between, then any node which is between the root and the leaf node will denote that. So this is, let's say, mediator node. It will have merged the answer from, let's say, range u and v, or values from u and v. In that case, the cost for that will be the individual costs, and this will be propagated in by combining it with something else. Then this cost would be AU plus AV. This would be something else, let's say AK. Then again, this cost for this node would be AK plus AU plus AV, and so on. So this will be the recursive thing that will be happening if we consider all the possible choices for merging ranges one after the other. And the recurrence formula for this would be to check for all the possible breakups that are possible for any range. So we are finding the answer for index L to R. Then this can be breaked up into the ranges L to K and K plus 1 to R. So to know the answer for L to R, we need to know the answer for L to K and the answer for K plus 1 to R. This is the main idea, and let's say we need to know the answer for this. It will depend on, or not depend, but it will be computed by finding out the best answer for these two choices, one and this one, and combining them with the cost associated for that merge, and that cost will be sum of elements in that entire range, right? So this will have, this block will have sum of elements from L to K, and this block will have elements from K plus 1 to R. Hence the total cost would be sum of elements from L to R. Hence that is the, so this term denotes the best or most optimal choice to construct a subarray from index L to K. So this is what will recursively be computed for indices L to K, and this would be the best or most optimal way to construct a subarray or merged interval from indices K plus 1 to R, and cost would be sum of elements in that range, which is derived here. Okay, that's it about this. So one more thing, K is only up to L, from L to R minus 1, because if K is R, then there is nothing to the right of this. It is not allowed to merge two ranges where the first is non-empty and the second one is empty. So this would be empty in this case. The second range would be empty in this case, and it is not allowed to merge them. Hence we only merge non-empty ranges. Okay, that's it about this recurrence. Let's go over the implementation. Cache is the memoization array. We will use it to check whether a state is already visited and return the answer if it is already visited, and it's the number of elements, and we are going to input array A given in the question. We are constructing prefix sums to compute this faster. So to know what is the sum of elements in a particular range, so for sum of elements in this range will be given by if sum of the first R elements subtracted with the sum of the first L minus 1 elements. This is what we are doing to find out this sum in constant time. Okay, next we are finding out the answer for the entire array, which means that L is equals to 1 and R is n. And these are the base conditions. We check whether we have arrived at a case where there is only one element left in the merging that we are performing. In that case, the cost is 0. We are going to check if this state is already visited. If it is visited, we can return the answer from there. We initialize the answer with a large positive value so that it is minimized appropriately. Then we are going to check how we are going to merge them. What would be the endpoint of the first segment, which will be iterated from k equals to I to j minus 1, and for each of them this will be divided from L to k and k plus 1 to R. So this will give the answer for that left part, and this will give the answer for the right part, and this is essentially the sum of elements in that range, which is sum of elements in range here L to R, which is given by this formula. And after minimizing over all the possible choices that are possible for given L and R, we are going to return the answer from here. This will compute the answer for the entire array by recursively calling all the choices one after the other and finding out the most optimal answer. Yeah, that's it about this video. If you have any doubts, do let me know in the comments, or if there are any suggestions about these videos, do drop them in the comments. Thank you.